Websites. I needed one, and so I set one up. I went all out and even subscribed to DreamHost web server. It worked, kinda. I scripted the website using PHP, but ended up having a big problem. Bots on the net were using my website contact forms to spam people. I'm not entirely sure how. I honestly am no tech expert. I just do things myself because I'm ambitious and cheap. DreamHost eventually shut down my website when reports of my website's activity got back to them. They then offered to let the website back up if I subscribed to a website security package they offered me. I said no, I didn't like paying them in the first place, and I jumped into self-hosting. This is how I, a blue-collar grease monkey, did it. First, I needed a computer. When someone says server, they just mean a computer you can access remotely. Don't be fooled, I didn't need anything fancy. There are many tutorials on how to do it with a Raspberry Pi, so I got a number 5. I got one along with the applicable cables, a microchip, and later on a little fan. I already had a monitor and keyboard, though they were not necessary. That being said, I needed a device to program the Pi with, and I needed access to my router's port forwarding services. I already had a laptop and a microchip reader, so my net cost for this stuff was about $100. Still less than the $150 for DreamHost for a year. Yeah, I'm a little sore about that. The next applicable step was programming of the Raspberry Pi. It was easy on Linux. First, I installed the Raspberry Pi application using the dev file from their website. Then, I put the microchip into my computer reader and opened the Raspberry Pi application. The programming process starts with selecting the Pi you possess, a 5 in my case, then the purpose. I'll boot this Pi from a USB drive using a USB port, so we go to the miscellaneous utility images. Select the bootloader, Pi 5 family, and next, click NVMe USB boot. It's back to the OG screen. I selected the storage device and the operation begins after hitting next. To test if it works, but not a required step, I boot the Raspberry Pi with a chip hooked up to the monitor, and the monitor displays a green image. Returning to programming the SSD drive, simply plug in the drive and use the same Raspberry Pi imager application. I selected the Pi, the Raspberry Pi OS 64-bit, and my storage. Wait, still not done. I need the SSH settings for remote access, which I find after pushing next and taking the Edit Settings option. Now filling in my info, I check all the boxes. Don't watch this is private. The host name is what you want the device to be called. The username is what I'll use to log in remotely and install software, and on this line, I'll add the Wi-Fi login info. No looking, I won't have y'all mooching my Wi-Fi. SSID is the name of the network, then just some extra time zone questions. After that, I went to the services and enabled SSH access with a password. Options have nothing relevant, ignore them. That is done, and let the writing begin. If I want to boot from the chip instead of the SD, I would simply install a Raspberry Pi OS 64-bit directly onto the chip and boot the Pi from the chip. I plug in the SD drive and boot. Pi OS comes up. Now it's game time. First, I'll run the fconfig command to find the Pi's local IP address. This way I can SSH into it from my laptop locally without port forwarding. I'll port forward anyway, I like having the options. If I didn't have a monitor and keyboard, technically by port forwarding port 22, I could reach the Pi without knowing its local address. So to port forward, I need to access my router settings. In my case, it's an AT&T router. To find the settings, I log into the AT&T website. Side note, if the website doesn't load with a normal search, a lot of times it'll load in incognito mode. I search using the search bar for port forwarding, click the port forwarding help article, then find my router in the dropdown and go to the advanced settings section, where I see the link to the Wi-Fi hub settings. Inside, they ask for special passcode. After finding that pass on the back of my router, I find myself inside my port forwarding settings. I also add the custom service for both ports 22 and 80. 22 will be for the computer I'm using and 80 will be for the website I'm uploading. Later, when I apply the settings with the AT&T port forwarding form, I'll have to be specific on which device needs which port. SSHing. This is the magical spell that gets me logged in remotely. If I'm away, I use my external address to log in. If at home, the internal address. SSH keygen adds an SSH key to make login quicker. Make sure you remember the location where you decide to store the SSH key. Also, saving the fingerprint might be helpful later. I set the password, though it'll slow it down. According to the SSH website, you can set the security levels and the type of algorithm. Personally, I went basic. Use this little line to copy the public ID back to the computer. Having figured that out, I start the downloads with a quick update. I chose nginx just cause, and I also added fastCGI since I decided to use PHP for some reason. I also installed MySQL for a database. The fastCGI requires some tweaks. We have to edit the default settings on nginx. The first thing was finding the FPM version I installed. I nano into the settings file of the nginx server, added the FPM version, and enabled the rest of the fastCGI settings. This includes adding an index.php to the rest of the file types. A couple of extra items have to be typed in. This is to add load balancing. This way both my computers will be used to run my website. Yes, I have another old computer I added to the system using Ubuntu LTS. Notice that the local server gets its own port and I use a public port for the load balancing code. I also added weighting to the load balancer to keep the larger load on the bigger computer. This is also a key place where I use local IP addresses, that way I don't have to open up more than one port for the website. But if one of my computers was located at a different house or network, I could port forward from there and put its public address in the slot so we could load balance with out-of-system hardware. At this point, I'll show you how and where I added my website's files. I use SCP when transferring the files to the web server, and the default file location is bar.whtml. This can be changed from the default file from earlier. SCP can also be used to transfer folders using the recursive function. You'll notice the image types I use are AVF. They're smaller and load faster when people get on the website. I also use GIFs, not videos, in order to decrease loading time. For security and to reduce the bot factor, I run my traffic through Cloudflare, which is pretty easy to set up. First, I created an account and then clicked add domain, and there was an option to buy one. Unfortunately, I had already bought one, so I had to take the extra steps of updating my name servers on DreamHost. They are found underneath the website management. Click manage website and then DNS, where I updated the new information. It's still not complete. I had to go back to Cloudflare, hit continue, then tell it to check DreamHost. The domain's still on DreamHost, so I must review the domain list and enable transfers and go back to transfers in Cloudflare. I click on the domain and enter the secret code that DreamHost will give you from their transfer section, except it's found in the transfer out section. All these requests will take 3 to 4 days to settle out. To add my website to the domain name, I had to create a new entry in the DNS list and specify it as A-type. The website's now live and the world can see my masterpiece, and yours if you made sense of anything I just showed you in this video. I still have a problem. My v4 IP address is high probability of changing since it's a dynamic IP. A permanent IP is $30 a month for me, so that means I need to find an alternate method, obviously. So far, I've tried using a custom script that uses an API token to update the IP address. It did successfully update the IP address, but it would remove the Cloudflare proxy service, effectively disconnecting my website from the domain name. Once I figure out a solution to that, I'll create an update video. That's all, folks. Thanks for watching.